Good day, everyone. Before we discuss the topic, may I introduce to you the reporters, Tanya B. Serrano, Archie Gonzalez, Rochelle Reyes, Ferdinand Luis Domingo, Angelica Magno, and Ross Edrada. And today we're going to talk about wind farm. Wind turbine, parts and operating principle. Wind turbine is a type of renewable energy that harnesses the power of wind to produce electricity. The basic idea is that wind turbines uses rotor with attached blades to collect wind's potential and kinetic energy. Wind turns the blade which spins the shaft that is connected to a generator which results in a generation of electricity. A large number of wind turbine is usually called wind farm. Parts and functions. Blade. The blade is the part that rotates due to the force it catches from the wind. It is connected to the low-speed shaft via the hub. The low-speed shaft is connected to the gearbox and the gearbox to the generator. Once the blade rotates, it causes the rotation of generator, thereby generating electricity. Most wind turbine consist of 3 blades for maximum efficiency. Blade design. To produce an amount of power, wind turbine blades generally need to be large and tall. It is shaped to generate the maximum power from the wind at the minimum cost. Improvements in the design has produced new wind turbine which are more compact, quieter, and generates more power from less wind. Its lengths vary at around 50 meters with 107-meter blade, currently the longest from Siemens Gamesa.
Airfoils is the cross-sectional shape of the blades that determines its aerodynamics. They are key to blade design. This airfoil design allows the blade tips of a wind turbine to move faster than the wind is moving, thus generating more power and higher efficiencies. So, we need to consider airfoils in blade design. So, ano nga ba ang airfoils? It is the cross-sectional shape of the blades that determines its aerodynamics. As you can see in the picture, yun po yung parang may grid. So, if we cut it out, yung pong nasa taas yung magiging kalalabasan ng airfoils. So, cross-sectional have different variants and it takes a vital role in aerodynamics. So, what is aerodynamics ba? It is the behavior of the wind once it collides in a certain object. So, ang ganitong klase ng airfoil design ay tumutulong o nagpapabilis ng galaw ng blade faster than the wind velocity. So, these are the wind turbine airfoils design. So, for the thin airfoil family for medium blades, first one is stiff region airfoil, 95% radius. Second one is primary outboard airfoil, 78% radius. The third one is root region airfoils, 40% radius. So for the thick airfoil family for large blades, tip region airfoils, 95% radius. Primary outboard airfoils, 75% radius. Root region airfoils, 40% radius. So, blade aerodynamics. Wind turbine blades work by generating two aerodynamics forces, which is lift and drag. This is due to the wind and their airfoils. Lift force is perpendicular to the airflow and is in line with the blade rotation, while the drag force is in line with apparent wind direction, which is in front of the blade motion. Drag force increase in proportion to the frontal area of an object facing the wind. So what does it mean? Wind turbine can generate two kinds of aerodynamic forces, which is lift and drag forces. These two kinds of forces generates due to the wind and its airfoils. So the direction of the lift force is perpendicular to the airflow and in line with the blade rotation, which the drag force is in line with the wind direction, or simply means it is parallel. So, what is the effect of these two forces? Ang leaf force ay nagdudulot upang mag-rotate ang blade ng wind turbine at ang drag force naman ay siya yung kumokontra sa pag-ikot ng blade. So let's tackle about the formula. So this is the formula for leaf force. CL stands for coefficient of leaf, P stands for wind density, V squared stands for velocity of the wind, AB stands for area of the blade over 2. While this is the formula for drag force. CD means coefficient of drag, P stands for wind density, and V squared stands for velocity of the wind. Then AR stands for reference area. So note, when it comes in the computation of drag force, na reference area is the frontal of the blade which is being struck by the wind. So kukunin po dyan yung frontal ng blade na tinatamaan ng hangin. Another thing that the airfoil is able to bring is for the blade to attain difference in pressure on both sides. The most curved side, or we may say the convex side, generates low air pressure while high pressure air pushes on the less curved side, or we may say the side with slightly concave part. This is actually the reason for blade rotation. So what does it mean? When the air hits the airfoil and hits its most curved side, it will generate low air pressure, while the wind that hits or go into the less curved side will generate high air pressure. Because of this, the blade will rotate, or it will start the rotation. So for the blade wind orientation, here is now the question. Based on the figure illustrating the optimum angle of attack, which part of the blade is the leading edge and trailing edge, front and back? So ano nga ba? So for the wind orientation, when we say angle of attack, ito yung nagsasabi kung gaano nakatilt yung blade sa direction ng wind para ma-maximize nito yung rotation ng blade. So for the wind rotation or blade rotation, what will be the rotation of the blade? Is it pushed to the side that has more curve or pushed to the side that has less curve? So ano nga ba? So paano ba yung rotation ng blade? Yung hangin, kailangan tatama siya sa blade na kung saan may less curve para tumulak siya pataas. So magsisimula yung hangin or yung pag-ikot ng blade sa less curve area or side blade.
Blade wind orientation. The photo shows the front side and back side as well as the leading edge and trailing edge of the blade. Blade design. In addition to its curved design, twisted and tapered blades further enhance its aerodynamics. With the combined effect of twisting and tapering the blade along its length improves the angle of attack, increasing speed, efficiency, and lift while reducing drag.
Wind turbine number of blades. Meron tayong 3 rules. First is, the fewer blades the better since there will be less drag and an increase in efficiency. Second, the number of the blade increases the torque and reduces the optimum rotation speed. And lastly, having fewer blades reduces drags. One blade is not advisable to be used in wind turbine tower because it may create wobble o pagiging mauga na maaaring maging sanhi ng pagkasira sa isang wind tower. Also, single blade turbine can cause of slow rotation because it is unbalanced na maaaring makaapekto sa pagpoproduce ng electricity. Maaaring mas maliit na amount ang maproduce nitong electricity because the rotor did not rotate perfectly or properly. Double blades turbine seems like perfect, but in some instances, it also create wobble because the blade are unbalanced when it spin. But unlike the one blade turbine, maaaring 2 blades ay makapag-produce ng mas mataas na amount ng electricity dahil maging mas mabilis ang pag-ikot nito dahil sa dalawang blade ang makaka-adapt ng hangin. More than 3 blades. Sinasabi dito, over the years, wind turbine use 3 blades. Why not 2 or 4, even just 1? dahil hindi balance ang pag-ikot pag ganyan ang bilang ng wind turbine. Bakit nga ba 3 blades? With 3 blades, the angular momentum stays constant because when one blade is up, the other two are pointing at an angle so that the turbine can rotate into the wind smoothly. Blade tilting mechanism. Ang blade tilting mechanism ay isang sensor na pinagsama-samang mga bahagi ng wind turbine, at ang blade tilting mechanism is sensor that helps the blades rotate properly. Ito ang nagbabalanse sa pag-ikot ng mga blades sa wind turbine, and also it will become the mechanism that help to produce electricity by turning the kinetic energy through the wind that can spin the blade into electric energy or electricity.
So, ang next naman natin is yung nacelle or nacelle. Ito ay located behind the blade and tawag naman dito ay housing dahil nagko-contain dito or nakapaloob dito is yung slow speed shaft, gearbox, generator, and other small parts. So, function naman nito ay to protect the wind turbine from foreign object ingestion, and its design is to expand the gases in the exhaust system as effectively as possible while providing the fan with the air at the lowest possible distortion and efficiency. Next part ng wind turbine is the gearbox. So, what is the purpose or the function ng gearbox? So, ang function ng gearbox is yung bagal na ikot ng turbine is pabibilisin naman ng gearbox. So that, pag naipasa ng rotation sa generator, the generator will rotate that will produce a great amount of output. So, in simple terms, sa madaling salita, ang function ng gearbox ay pabibilisin nito yung ikot ng turbine para once na kumonekta si generator dito ay bibilis din yung ikot ng generator. So, ang common ratio ng speed ng isang gearbox is 90:1. So, ano nga ba ang meaning ng 90:1? 90:1 means kada ikot ng blade ng wind turbine, katumbas niya ay 90 times na ikot ng gearbox. So, meron siyang rate na 16.7 RPM input from the rotor to 1,500 RPM output for the generator. Naman natin is yung gearless type or yung direct drive to vehicle. So, ano nga ba ang direct drive or yung gearless? So, it means this type of design do not require a gearbox and therefore have fewer moving parts. So, di ba, kung titignan, yung ikot ng blade usually mabagal. So, need pa i-transfer sa gearbox para mabigay yung information lahat. So, dito naman sa gearless, kung ano ang ikot ng blade, yun na din ang ikot ng generator. Diba? Mabagal yung ikot ng turbine. So, paano makakapag-produce ng output? Then, dito papasok yung para ma-compensate yung bagal ng ikot ng blade, need na magdagdag ng set of magnet. Kasi originally, ang design ng generator is 8 or more magnet balls para ma-compensate yung slow rotation and makapag-produce ng great quality output. So, comparing to gearbox, yung gamit kasi dito is not just an ordinary magnet or electromagnet. It is made up of permanent magnet made of neodymium, which is, we think, like, according sa iba, yung 95% ito is came from China. Kaya yung dami ng magnetic balls is makakagawa na siya ng malaking generator compared sa laki ng generator ng gear type. Kaya sobrang taas din ng presyo nito kesa sa gear type kasi nga, diba, nabanggit ko din kanina, it is made up of permanent magnet which is came from China. So, talaga mapapamahal yung gastos nito para makagawa ng isang gearless type of wind turbine. Then, kung titignan, compared to the gear type na nasa maximum level of development na siya. So, no need of improvement or what. Dito naman sa gearless type is nasa infancy pa siya. Or like, kumbaga, na need of improvement pa rin siya kung pag-aaralan ng mga iba't ibang eksperto. Then, also, habang tumatagal yung pag-aaral, may tendency na matumbasan pa niya yung maximum level of development ng gear type na wind turbine. And also, yung pag-operate ng gearless type of wind turbine is much quieter, or kumbaga, hindi ganun kalakas yung ugo, 'di ba? Mostly sa pag sa gearbox or like gear type, mayroong vibration na maririnig lalo sa pag-ikot ng mga nozzle. Well, compared dito sa gearless type of wind turbine ay wala masyadong maririnig. Kumbaga tahimik yung pag-operate nito and less vibration. Also, some of advantages din ito is they have significantly lower maintenance cost, and it is not needed to replace gearbox as these are gearless turbines. So, kumbaga, no need to replace the gearbox kasi usually, yung mga dating mga gear type na gearbox, gear type na mga wind turbine, yung may mga usually gearbox, need pampalitan yun. So, dito, no need to replace kasi usually, hindi na, kumbaga, mababa lang yung maintenance na ginagawa dito.
Yung brake naman, hindi siya tulad ng brake sa mga kotse. Yan, or like sa kung saan mga bisikleta pero kahit sa anong sasakyan. So, pag sinabing brake when it comes sa wind turbine, yung purpose nito or yung function nito is to automatically stop the rotation of the blade. Kumbaga, pag malakas na yung hangin at yung ikot ng blade ay sobrang bilis na, automatically na manggagana si brake para i-shut down yung system. Kahit gumagana pa yan. Kumbaga, meron siyang detector para maramdaman na hindi na tama yung pag-ikot ng blade or may mali na dun sa ikot ng blade. So, hindi lang siya totally dun gumagana, pwede rin siyang gumana kung yung isang vitals ng isang part ng isang wind turbine ay may mali or like kumbaga may sira. So, automatically i-shutdown niya na yung system para yung mga gagawa nun is hindi makuryente or like hindi madisgrasya. Also, when it comes to maintenance then gumagana ang brake. So, once under maintenance yung system, automatically naman mag-shutdown din yung automatically gagana yung pinaka-brake ng isang wind turbine just to shut down the whole system. Next part is the yaw system. So, under the yaw system is the yaw motor and the yaw drive. Yung yaw motor is just right below the nozzle. So, kung titignan natin yung mga wind turbine, hindi siya fixed. So, kumbaga, hindi siya naka-steady lang. So, dapat umiikot siya. And yung ikot niya is nakabase sa direksyon ng hangin. So, kumbaga, yung pinaka-blade ng wind turbine is nakaharap sa direksyon ng hangin. Dito na papasok yung function ni yaw system, which is yung isang part niya is yung yaw motor. So, yung yaw motor, yun yung magpapagana kay nozzle para kumbaga siya din yung magpapaikot sa yaw turbine para sundan yung wind direction or kumbaga yung ikot ng hangin. And manggagaling naman yung information na yon dun sa wind vane. So, kumbaga, located ito sa likod ng wind turbine. So, ano ba ginagawa muna ng wind vane? Wind vane, yun yung nagde-determine ng direction ng hangin. So, yung wind vane, siya naman yung magbibigay ng information kay yaw drive para magbigay din siya ng, kumbaga siya yung magbibigay din ng way para gumalaw yung pinaka-wind turbine natin. Or kumbaga, i-directa niya yung information na yon sa wind turbine para sundan yung pinaka-direksyon ng hangin.
So here is another part of the wind turbine and its function, the tower. So as we know that as we go to higher altitude or mataas na heights, the wind or specifically the wind velocity ay mag-i-increase. That is why the wind turbine is designed to reach those higher altitudes, because the taller the tower of the wind turbine, the greater electricity it can produce. And the majority of the wind turbines are designed to be supported by conical tubular steel towers that, as we know from the shape, that a cone shape has a bigger diameter from the base, but it gets smaller as it goes higher. This is chosen because it not only minimizes the cost of materials to be used to build it, but it still maintains the strength to withhold the structure. So, if you are going to ask me, what is the average height of a tower for a wind turbine to operate efficiently? So, the answer to that question is 75 to 110 meters or 250 to 370 feet depending on the blade's diameter. And the tallest wind turbine in the world was still for completion in the mid of 2022, which has a height of 280 meters and is to be installed at a test center in Western Jutland, Denmark. So next is the tower and blade diameter ratio. Based on the picture that we provided, it shows the ratio regarding the tower's height and the rotor's diameter. And kung ating ma-observe natin sa table, from the year 2000, the average hub height is 58 meters while the average rotor diameter is 48 meters, where the hub height in that year is bigger than the rotor's diameter. But now as the years pass and engineering designs are improving, we can observe that in the year 2018, the average hub height is 88 meters while the average rotor diameter is 116 meters, where now the rotor's diameter is now bigger than the hub's height, which is a lot different from the past years. And that is where engineering marvel comes into play. So next, what is the best places or ideal location for wind farms? So most of the wind farms are located in coastal areas, at the top of rounded hills, open plains, and gaps in mountains. Places where the wind is strong and reliable, and some are located offshore. To be worthwhile, there should be an average wind speed or wind velocity of around 25 kilometers per hour. So next is the advantages and disadvantages for these wind turbines. Advantages. Wind is free, so there is no reason to spend fuel just to supply energy for remote areas. Produces no waste or greenhouse gases or gases like carbon dioxide or carbon monoxide that can destroy the ozone layer. The land beneath can usually still be used for farming or other activities. Disadvantages. The wind is unpredictable and the wind speed changes throughout the day and from season to season. So, when you usually thought that in this time winds must be strong or there will be winds to operate the wind turbine, but there are none. So, the operation of the wind farms has become unpredictable. Suitable areas for wind farms are often near the coastal area where land is expensive. So, pili lang talaga ang mga ideal location ng mga ito. And, it can affect the television or reception on nearby places or the television signals get jammed.
Largest wind farm. Yung pinakamalaking wind farm dito sa mundo is yung Gansu Wind Farm na merong generational capacity up to 10 gigawatts. And yung capacity nito is mas mataas ng 6 na beses sa pangalawang largest wind farm, which is yung Jaisalmer Wind Park na matatagpuan sa India. And yung iba dito, ito na yung the rest na wind farm sa kanilang bansa. Gansu Wind Farm. The Gansu Wind Farm project is a group of large wind farms under construction in western Gansu province in China. In 2008, construction began on a 750 kilovolts AC power line to carry electricity from the wind, and construction of the wind farms themselves started in August 2009. In November 2010, officials announced the completion of the project's first phase, involving the installation of over 3,500 wind turbines with an installed capacity of approximately 5,160 megawatts. So grabe laki, compare natin dun sa Burgos Wind Farm. Dito may 3,500 wind turbines tayo and 5,160 megawatts sa Gansu Wind Farm. Sa Burgos Wind Farm naman is the 150 megawatts Burgos Wind Farm is the largest wind power project in Southeast Asia, located in Burgos, Ilocos Norte, Philippines. The estimated cost for the construction of the wind farm was $450 million, which was completed in 2015. So yung facility na to nagko-consist ng 50 wind turbines. Grabe. Sa Gansu naman is 3,500 wind turbines. Tapos yung capacity naman na ito is 3 megawatts lang. Doon 1,500 plus yata yung megawatts na capacity niya. So maliit. Pero ito naman yung pinakamalaking wind power project dun sa may Southeast Asia. Ito yung summary ng wind turbine. So ayun, may hangin. Pag pumunta yung hangin, papaikutin nyo yung gearbox, tapos yung generator, and pupunta dun sa transformer. Yung purpose ng transformer is to step up the incoming voltage from the generator. Bakit nga ba may transformer? In order to eliminate further losses due to very long transmission, and pagka nag-step up na, pupunta dyan sa mga tower, papunta sa bahay-bahay. Yun. Kaya nagkakaroon ng electricity